Using convolutional neural networks to map houses suitable for electric vehicle home charging. In this presentation, our goal is to offer you a quick summary of the research and conclusions. Please follow the links to review the research in further details. This paper demonstrates a novel end-to-end workflow using deep learning to transform automated surveys of urban areas to identify residential properties suitable for EV charging. Computer vision algorithms are proposed for the identification and classification of private off-street parking for EV infrastructure. The paper outlines the methodology to identify residential properties for EV charging. This paper also presents the first case of using deep convolutional neural networks, or CNNs, to classify residential off-street parking from remotely sourced imagery. The methods presented are used to select, train, test, and optimize the two CNNs that are utilized within the workflow presented. Deep convolutional neural networks, or CNNs, have emerged as a powerful tool for remote sensing applications due to their superior performance in visual pattern recognition, object recognition, image classification, and image segmentation. Based loosely on the perception mechanics of the visual cortex, a CNN architecture consists of multiple layers of artificial neurons in a stacked arrangement to perform three main functions: convolutional, nonlinearity, and pooling/subsampling. As yet, no attempts have been made to use CNNs to identify residential properties suitable for EV charging from streetscape imagery. Furthermore, there is also a lack of work that has been carried out on applying machine learning techniques to identify external characteristics of individual residential properties. There are no freely available datasets that are suitable to train a CNN to recognize images of residential homes suitable for EV charging point installation. The first dataset is used to train a CNN to classify GSV images into one of four categories: car parks, trees and foliage, images taken at unsuitable headings, and images of residential properties. The second dataset is used to train a second CNN to distinguish between residential properties that are suitable for EV charging and those that are not. By splitting up the image classification task into these two discrete problems, the researcher was able to use much smaller datasets than if we wanted to train a single CNN to perform the whole task. For both networks, since the training datasets are not large enough to train a network from scratch, a fine-tuned transfer learning approach is adopted. For this image classification, this approach makes use of existing networks that have already been pre-trained on large image datasets and therefore have already learned certain low-level features such as object edges, shapes, corners, and intensity. For the Petersville test area, CNN1 achieved a recall of 90.7 for identifying images of residential front views suitable for processing. Following the CNN1 step, 2,851 images were passed onto CNN2 for processing. CNN2 then identified 1,693 images as suitable for EV charging, achieving a recall of 88.6% as shown in Figure 7. Overall, the system recognizes 1,355 of the total 1,651 images suitable for EV charging. Once the images were downloaded, they were passed through CNN1 for pre-processing. For the Birmingham test area, CNN1 achieves a recall of 96.3% when identifying images of residential front views following the CNN1 step. 7,408 images were passed on to CNN2 for processing, which then identified 5,376 images as suitable for EV charging, giving a recall of 89.3%. Overall, the system recognizes 4,617 of the total 5,306 images suitable for EV charging. In summary, this paper presents the first case of using deep CNNs to classify residential driveways from remotely sensed imagery. A system was developed into identifying and map residential properties suitable for EV charging with higher levels of accuracy. Further enhancements of the model are possible. Despite that methods developed in this paper represent a major advancement towards fully automated remote surveying capability to audit the built environment.